Good morning, students. I, Harita Malani, working as an assistant professor in Electronics and Communication Department of MLB Textile and Engineering College, Bhilwara. Today I am delivering my online lecture on subject fiber optic communication, and topic to be discussed is optical couplers. So what do you mean by a coupler? Coupler is a device which transmits optical power or which couples optical power, optical signal from one end to the other end. So before starting with optical couplers, I will discuss the passive components. What do you mean by passive component and where it is used and why we are studying it in the topic optical couplers. Passive components are very important and they are primarily used to split, combine or tap off optical signals. The prime component in this category are couplers, multiplexers and demultiplexers. The implementation of WDM requires some optical components. These optical components are passive components. They could be wavelength selective or wavelength dependent. Next, we will discuss the passive devices. So, passive components are required to design a passive device. So, what do you mean by passive over here? Passive means we don't need any optical to electrical conversion in the device. Also, we don't need electrical power. So, passive devices doesn't require optical to electrical conversion or electrical to optical conversion. Secondly, it does not need any electrical power. Then, these passive devices are used to split combined light streams in the form of couplers, power splitters, power taps and star couplers. Technology used are fiber based, optical or micro optic based, and the materials used are special materials which are required to design a fiber cable. Next, we will start with active and passive optic couplers. So what do we mean by active and passive couplers? Active coupler means we need optical to electrical conversion. Whenever we are transmitting the signal from a coupler, we need optical to electrical conversion. Also, we need power supply. External power supply is required. So, that is my active coupler. So, active coupler requires an external power source. It requires an optical to electrical converter. So, that is my active coupler. Next, I will discuss passive couplers. Passive couplers. So here in passive couplers, optical signal to electrical signal conversion is not needed for distribution of optical signals among the output fiber. Also here we don't need any external power supply. So this is the basic diagram of passive fiber optic coupler in which we are having n input ports and n output ports. So figure illustrates n inputs and m output, and the range is from 1 to 64. That means we can have one input or we can have till 64 inputs and same number of outputs we can have. So this is a schematic of passive fiber optic coupler. So next I will discuss the couplers. What do you mean by a coupler? Coupler are devices that are used to combine and split optical signals. And the basic coupler designing is 2 cross 2. That means 2 input ports and 2 output ports. And how these couplers are made? Couplers are made by fusing 2 optical fibers together in the middle and then stretching them so that a coupling region is created. And this coupling region is very important because this coupling region will define the coupling ratio. Such devices can be made wavelength independent or wavelength dependent over a wide spectral range. So now what is coupler? Coupler is a device in which we can launch input signal at input port, which may be split into 2 signals that can be collected at output ports 1 and 2. So input port, through input port we are transmitting the input signal, that is optical light. At the output side I am having 2 ports. Through 2 ports I will split my signal. Next, the coupling ratio. This is a fraction of the power available at the output ports is called the coupling ratio. So now, while designing this coupler, what is important? It is important to set the coupling ratio. It could be set from 1:99 till 50:50 ratio. So 1:99 and 50:50 ratio. Second very important thing is the coupling length. And coupling length defines very important parameter that we will discuss later on. So a coupler distributes an input signal equally among two output ports if coupling length L is adjusted such that half the power from each input appears at each output stage. So if from input signal is transmitted and at the output we are getting output at both the ports, then it is known as a 3 dB coupler. So this device will have a coupling ratio of 50:50. So a device with a 50:50 coupling ratio is called a 3 dB coupler, as 50% of the input power is coupled to each output port. It can be used as a power splitter. And if the coupling ratio is 1:99, then this coupler can be used as an optical tap, a very important application of a coupler. Next, this is the diagram of basic coupler. So here what we are having? We are having two input ports and two output ports. Through input ports, I am having input port 1 as a fiber 1. So fiber 1 is transmitting my first optical signal. The power denoted as P0. At the output side, I am having port 1 and port 2. Output port 1 is having power P1, output port 2 is having power P2. In the between, we are having the coupling region where we have fused two optical fibers. This is coupling region, length is L. And the second fiber 2, the power launched is P3. This we will discuss later on. What is the significance of this power P3? Next, we will discuss classification of optical fiber couplers. See, basically we have started with the introduction of optical fiber couplers. Then I have discussed what we mean by passive component and passive devices in optical fiber communication. After that, we have started with couplers, in which I have first discussed the basic active and passive couplers. After that, we are discussing the second classification of optical fiber coupler. So first classification is core interaction type, second is surface interaction type. By the name, I think we understand what is the significance over here. Core interaction type means the transmission from fiber 1 to fiber 2 is through core. They are connected in a series way. Surface interaction type, the power is coupled through surface from fiber 1 to fiber 2. Both coupling can be bidirectional. So this is the basic classification of optical fiber couplers. In next class, in next lecture, we will discuss the different types of fiber optic couplers. So students, if you have any doubt, any query, you can ask, you can message me personally. And hope you will enjoy this video lecture, and this is a very basic concept of fiber optic coupler. So thank you very much, and please student do study this topic.